into a perfectly flat plate, just like we did in our small-scale experiments. And to do that, we've got two massive steel plates, one that's embedded in the ground, one that is suspended overhead off of this gantry. It weighs 7,000 pounds, and we're going to put explosives on top of that. It's going to come down on our unsuspecting car like a freight train.
That's the theory. And before long, the 7,000-pound plate is up and running.
It's a beautiful thing.
Secured to the gantry courtesy of 6 breakaway straps.
Okay, now you can sort of see how this is all coming together. We've got our plate in place. We've got the car that's going to go underneath. Explosives on top. Bob's your uncle.
With that, it's time to position the car. First, with a forklift.
Like a surgeon. Now, don't scratch it.
And then, by hand.
How's that?
A little bit more.
All right.
There we go. Cool.
That just leaves the explosives. All 1,000 pounds of it.
That is a lot of boom. Gently up. Let's go.
At Treasure Island,
Come on, baby.
Adam and Jamie's lift-a-car suction rig has sucked.
Rats! What happened?
So it's back to the shop and back to the drawing board.
So, just to recap, and you saw this, our previous method was what we call the octopus arm method, and involved many different caps distributed across the whole of the car. And that turned out to be completely 100% wrong. So now we are going with a method we call the box method. I don't know how do we come up with these names, but it's just a gift we have. Instead of 40 points of failure, we now have 3. 3 big, sturdy wooden boxes made out of plywood, sealed with a gasket between them and the car. We pull a vacuum from them with the manifolds. I think this is gonna work. We're gonna build some boxes. We're gonna lift this car.
So it's out with the octopus and in with 3 boxes that will still be powered by a single vacuum cleaner.
This plywood right here is one of my favorite building materials. We refer to it as Finn ply because it's made in Finland, and it's a birch ply that has many more laminations than normal plywood. It's about twice as heavy and twice as strong.
To give this design the best chance, Jamie's making each box as big as possible.
To start,
He's also contouring them to precisely fit the car's shape.
looks good.
And last but not least, he's laying in a rubber gasket that should form a leak-proof seal.
That all looks just about perfect.
And once the seal is set, the guys double-check the fit.
Lovely.
And their confidence is back with a bang.
These boxes are best to be thought of as the workers we are using to lift the car. So far here, all 3 boxes are saying, hell yeah, I can lift that car. But we've been here before. All 40 of our suction cups were all like, totally easy, man, we can lift that car. And they totally couldn't. So even though the math says that these are working beautifully and they should lift the car, I still see many ways in which this could go south.
Well, to find out, it's back to Treasure Island for some predictable preparation.
Looks really nice.
First, the guys position the steel cradle above the car.
I think that looks good. It's right over the rearview mirror.
Then they add the boxes to the trunk,
A little more, a little top. Perfect.
roof,
Yeah, that's tight.
and hood.
Nice.
Next, they secure the boxes to the cradle.
I think we're good.
With that, the guys bring in the crane
That's good.
before Adam adds the vital ingredient, the vacuum cleaner.
It's time to bring the vacuum back into this equation. I think that's a lovely place for it, don't you?
The boxes are the crucial change to this test.
I think we're really close.
But to help see if they're working, the guys have added pressure gauges to assess